Electricity. It is literally used in every facet of our lives. It makes our homes more comfortable, our businesses more productive and responsive to customers, and even allows many industries that are impossible without it. One of the things holding back the third world is simply the lack of electricity. The demand is huge. Many developing nations suffer daily blackouts, often to homes and industry. Without stable power, no one will invest in an industry there. Meeting this existing demand is obvious. Growth from there to first world standards must be organic, not forced, as people realize they may count on electrical service. They will buy more appliances. As businesses realize they can rely on a stable grid, they will purchase electrical equipment to meet their needs. Trying to sell into a market with a lot of poor people, though, means that the cost is a huge factor. Nuclear is a leading technology, but coal is on par with it, and coal has lower capital cost. But what if we could meet coal's capital cost and the fuel cost of nuclear? There is a possible solution: molten salt reactors. By running with a reasonably low melting point, fluoride salt mix, the reactor is always at low pressure, making capital costs much lower. The salt responds quickly to changes in temperature of the coolant by responding with increased or decreased volume, modifying the nuclear characteristics, and automatically adjusting to the change in heat demand. Many MSR designs, though, are complex, trying to squeeze every last bit of breeding from a fully moderated, so-called thermal neutron spectrum. Such complex online chemical processing systems would be expensive to develop, build, and maintain. The design of our reactor is much simpler. By having a simple crucible to hold the molten salt, with no pumps for the salt, no processing, and breeding in the active mix, we can remove dozens of components. By using a Brayton cycle with a working fluid and temperature delta designed for robustness, we avoid complex Rankine cycle generation equipment and can literally have a single moving shaft in normal operation. I am Jonathan Schattke. I've been in engineering for over 30 years. I have worked in every aspect of engineering, from electronics, computer programming, electrical, architectural, chemicals, civil engineering, and now nuclear. I have just finished my master's thesis on a nuclear power plant with no moving parts, which, while feasible, is not currently practical. This design is a compromise of simplicity, practicality, and simplicity. I have many of the skills needed to take a complete design to make a complete design of every part involved, from the containment to the last machine screw. What I personally cannot do, I will work with contract engineers in the specific fields to get done. All of the work will then be gone over by a professional engineer with nuclear experience. Aspects of the design not in current wide use, such as the molten salt mix itself, will be analyzed by appropriate experts. This is the first phase of realizing the dream of setting the world on the path to prosperity it has never before seen. Stretch goals are funding for the travel expenses to visit heads of state and energy ministers throughout the third world to convince those countries who have signed on to the Nuclear Non-Proliferation Treaty to install IAEA best practices as their regulatory regime and allow me to find a site and submit my design and siting verified to that regulatory level. I will want countries that have a free market in electricity or are willing to change to one. I feel this design needs no subsidies or price guarantees. And the furthest stretch goal is to manufacture a pilot plant for proof of concept, connected to the grid and providing power.